Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics, and in this video we are going to discuss about the concept of variation of density with temperature. So in a way it is related to thermal expansion, particularly the volumetric expansion. So we know we have already discussed thermal expansion, which is basically the increase in size of matter, solid, liquid, gas when it is heated. Okay, and it is of three types: linear, surface, and volume expansion. So here, as density is involved, so the volume or cubical expansion that will come into play. Okay, so variation of density with temperature. We know density is the mass per unit volume. So in thermal expansion, that is the volumetric expansion, when a given mass of solid or liquid that is heated, its volume increases. So when volume it increases, obviously density will decrease. With increase in volume, density will decrease. Okay, so this is the concept. So just a quick recap: volumetric expansion, which is expressed as this. Okay, the change in volume of an object is directly proportional to the initial volume Vi and the increase in temperature. Increase in temperature, which is expressed as final temperature minus initial temperature, and increase in volume is final volume minus initial volume. Okay, this is the increase in volume as per the volumetric expansion coefficient expression. Okay, gamma is the coefficient of cubical expansion or volumetric expansion. We have already discussed it. So the final volume is expressed as initial volume plus increase in volume, which is expressed as this: Vf is equal to Vi into 1 plus gamma delta T. Okay, so now if we take this expression, okay, Vf is equal to Vi into 1 plus gamma delta T, and we express Vf as mass by final density rho f. Because mass is always constant, the volume can increase or decrease, but mass is constant, so mass is remaining constant, the mass of that substance, capital M. So here density rho is equal to m by v. So volume will be equal to mass by density. Okay, density is mass by volume, so volume will be equal to mass by density. So final volume is equal to mass by final density rho f. Again, which is equal to initial volume Vi is expressed as mass by initial density rho I. Mass by initial density rho subscript I into 1 plus gamma delta T. So mass gets cancelled on both LHS and RHS. Okay, so we are left with 1 by rho f is equal to 1 by rho I into 1 plus gamma delta T, or we can express it as this: rho f is equal to rho I into 1 plus gamma delta T to the power minus 1. So here we can use binomial theorem to expand it like this: 1 plus x to the power n. So here n is minus 1, x is gamma delta T, and 1 is here, like that. So if we expand it, we will get it something like this. So 1 plus nx is equal to 1 plus n is minus 1, 1 plus minus 1 into x, which is equal to gamma delta T. So here we will be neglecting this higher power terms, that is the square terms, the cube terms, because the coefficient of volume expansion, that is a very small. So the higher power terms, they are almost equal to 0, so we can neglect them. So we'll only consider this much portion, 1 plus nx, which is equal to 1 plus n, which is equal to minus 1 into x, which is equal to gamma delta t. So we'll have 1 minus gamma delta t. So here the final density of the substance is equal to the initial density into 1 minus gamma delta t. So here density is decreasing as per this relationship with increase in volume of the substance as per volumetric expansion. Okay, so as volume increases as per this relationship, Vf is equal to Vi into 1 plus gamma delta t. We know that density will decrease, but how? This is the expression. Final density rho f is equal to rho I into 1 minus gamma delta t. Okay, so this is the concept of variation of density of substance with temperature, which is related to volumetric expansion. Okay, so this is the thing.